Okay, in this last lesson, lesson 4, we're going to be looking at 3 different topics. We're going to be looking at how to do confidence intervals, how to find the margin of error, and how to find a sample size. Okay, all of this kind of deals with the same thing. Now, when you're doing confidence intervals on a calculator, I just kind of want to review the calculator steps here as well. You're going to go to Stat, you can go over to Test, and you're going to go down until you see Z interval. Okay, what you need in order to do a confidence interval: you need the sample size, which is n, your standard deviation, the mean, and then your confidence level. They're going to give you a confidence level written as a percentage. You want to make sure when you type it in the calculator that you do it as a decimal. So if you want a 95% confidence level, you would type in 0.95. So I'm going to show you how to do this first. Now, I know you're not going to be able to read this problem. We've talked about clarity in several of our other videos, but I'm going to let you know the important parts, and you'll be able to read my handwriting anyway. All right. This is called weights of women. Okay. This is using the simple random sample of weights of women from a data set that we have in our book. We obtain these simple statistics. All right, we have n, and I'm going to rewrite this over so you can read it. Okay, we have n equals 40, x bar equals 146.22 pounds, and standard deviation of the population is 30.86 pounds. Okay, so I wrote those a little bit bigger so you can read them. Okay, A says, find the best point estimate of the mean weight of all women. Well, anytime you see that phrase, best point estimate, whatever they're talking about, whether it's of the mean, of the standard deviation, of the variance, whatever, the best point estimate is going to be that value of your sample. So like if you're looking for the best point estimate of the mean, then it's going to be the mean of that sample. If you're looking for the best point estimate of the standard deviation, it's going to be the standard deviation of that sample. That's the best we have. So in this case, the best point estimate of the mean is the mean of our sample, which is 146.22 pounds. Nothing to really do there. Just got to read the problem. Okay, B says find a 95% confidence interval of the mean weight of all women. Okay, this is where the calculator comes in. And like I told you before, you need the sample size, which we've got, the mean of the sample, which we have, standard deviation of the population, and then your confidence level, which is 95%. So, like I told you, look over the review of the calculator steps so you can see it, because I know you're not going to be able to see this calculator, so I'm just going to walk through it. Stat, test, you go down to Z interval. Now there's 2 things. There's a Z test and a Z interval. Go down to Z interval. You want to do stats. Make sure stats is highlighted. Then you're going to type in your standard deviation, which is 30.86, the mean, which is 146.22, the sample size, which is 40, and your confidence level as a decimal, so 0.95. And then you go down to calculate and just hit enter. And what it's going to do is it's going to give you an interval in parentheses. It's going to be 136.66, comma, 155.78. That is your confidence interval. Now, of course, I don't want you to write this as your answer. Okay, if you ever have to describe this or write this out, then you want to write it and relate it to terms of the problem. So what we would say is that we are 95% confident that the mean weight of all women is between these 2 numbers. So I'm going to write that out for you. We are 95% confident that the mean, very important word there, weight of all women is between, and then you would put your numbers, 136.66 pounds to 155.78 pounds. Okay, we are 95% confident that the mean weight of all women is between 136.66 pounds to 155.78 pounds based on this information. Okay, that's how you do a confidence interval, and that's how you interpret a confidence interval. Okay, the next part of this video is how to find the margin of error. Now it says find the margin of error for the following: the duration of telephone calls directed by a local telephone company, we have that the standard deviation is 3.6 minutes. The mean is 560, and we're 95% confident. Okay, this is the formula for finding your margin of error. It's error equals z of alpha over 2 times the standard deviation divided by the square root of the sample. Well, we've got standard deviation, we have the sample size. How do we find this z of alpha over 2? Okay, well, alpha is going to be the difference between 100% and your confidence level. So if I want to do alpha, I would do 100 minus 95, which is 5%. And I'm going to rewrite this as a decimal, which is 0.05. Okay, that's alpha. It's always 100 minus whatever your confidence is. Now, so alpha over 2, it means I'm going to divide this number in half. If I divide this in half, it's going to be 0.025. Okay, this is alpha over 2. Now, I want to find z of alpha over 2. Well, you're looking for a z-score. So go back and think about lesson, what lesson was that? Lesson 2, when we did the opposite of how to find a z-score. We've got the probability. How do you work backwards to find a z-score? Well, that involves inverse norm. So I'm going to do inverse norm of 0.025. Now, the only problem is when you do inverse norm of a number this small, you're going to get the negative. You don't want the negative value, you actually want the positive value. So you want to drop the negative when you're doing these types of problems. Okay, when you do this, you're going to get negative 1.96. So ignore this negative to get the positive z-score, because you want the positive end. Okay, that's your z of alpha over 2. All right, well, now we're going to plug everything in. I'm sorry, I kind of ran out of room, so let me grab another sheet of paper. All right. So now I'm going to fill in this parts to my formula. So to find my margin of error is z of alpha over 2, which is 1.96, times my standard deviation, which is 3.6, divided by the square root of my sample, which is 560. Now again, when you're doing this, make sure you put this in parentheses. Okay, so let's find our margin of error. Alright, so my margin of error around 3 significant digits is 0.298. Okay, that's my margin of error. Okay, that's the first or the second part of this lesson. And then the third part of this lesson involves finding your sample size given all the other information. So it's kind of like you're using the same formula, but you're solving it for n. So you're trying to find your sample size. So this is what the formula would look like if I were to take all this information and solve for n. Notice all you're doing is basically taking this formula. I'd multiply by square root of n, divide by error. That's how these switch places. And since this would be the square root of n over here, to get rid of a square root, I square both sides. That's where the square is coming from. So basically, I just took this formula, did a little bit of algebraic manipulation to get my new formula here. You'll have both of these formulas anyway, so you don't have to worry about the algebra behind it. But this is what the formula looks like. So basically, I need my margin of error, my standard deviation, and my z of alpha over 2 again. Okay? Well, I'm still working with 95% confident, so all this information I did up here to find alpha over 2, I would use exactly the same number, so I don't have to do it again. So z of alpha over 2 is 1.96. Okay, standard deviation is 672. And my margin of error, well, you're going to look for anything that you see. In this case, it tells you directly, but if you see the word like within, like I want it to be within 3 points or within $3, that's your margin of error. This one tells you, suppose that the margin of error for 95% confidence interval is 145, so that's going to be your error. So I'm going to fill in all those numbers. So 1.96 times 672 divided by 145, and I'm going to square all that. Now when you're doing this in the calculator, again this is more for the people who haven't had algebra, then you're going to do everything on the inside first and then square. So I'm going to multiply 1.96 times 672. I'm going to divide that by 145, and then I'm going to square that number. And when you do this, you're going to get 82.512 if we do 3 significant digits. Now, since we don't really know what we're talking about here as far as what kind of sample we're producing, I'm assuming since we're talking about some kind of money here, maybe we're picking a sample of people that spend this much money or something on a particular object. You know, we really don't know the context of the problem. We need to know it a little bit more. But most of the time when you're doing a sample size, you're going to round up to the nearest whole number, because most of the time you're going to be talking about like a group of people. And obviously you can't have 0.512 of a person. Even if this number was like 82.1, you would still round it up, because if you round it down, it's not going to be large enough. So I'm going to round this to approximately 83 of whatever my problem is. Now, when you're doing these problems in the textbook, it should be a little more specific. So you would know what you're talking about. So you could say approximately 83 people, or approximately 83 test scores. You know, whatever it is you're talking about, you can label that answer. Since here we don't really have that information, we're just going to say we need 83 of whatever it is. So these are the last 3 parts, and this is really dealing with Chapter 7. Okay, confidence intervals, margin of error, and sample size are all part of Chapter 7. The other 3 lessons we've done in this section were all Chapter 6.